So today we're going to talk about the respiratory system and its structures in the zones. So first zone is the conducting zone, and it's basically the physical movement of air entering your lungs, and there's structures part of that. The first structure is the nasal cavity, and it basically warms, filters, and moistens your air as it enters your lung to prevent damage to lung tissue. And your next is the pharynx. And then pharynx is a passageway for air to go through to the larynx. And then your larynx basically produces sound, and it also keeps your airway open. Next we have the trachea, and then the trachea is also the main passageway for air to go through, and go through from trachea to bronchi. And trachea also has goblet cells in its lining, and it also secretes mucus to trap dirt, dust, and other microorganisms. And then next we have the cilia, and cilia are basically tiny hair-like structures that are found in epithelial cells. And the cilia also beats upward and then grabs your mucus toward your epiglottis, and then that's what makes you swallow because it moves upward. So basically your cilia are tiny hair-like threads that are found in epithelial cells. And then your cilia also moves upward, and that brings your mucus towards your epiglottis, and it really makes you swallow it because it moved upward. So basically, your cilia are tiny thread-like hairs found in epithelial tissues, epithelial cells or tissues, and it's found in epithelial cells, right? And then and that's your cilia, and then your cilia also moves upward, and which brings your mucus towards your epiglottis, and then you swallow it. Sorry, that took me a while. And then basically your bronchi are long tubes that split air into each lung, and then bronchioles are small tubes that carry in lungs that carry air to alveoli, and they branch from bronchi and help transition into respiratory zone. And your bronchi are also large tubes to make air go through each lung, and then that's bronchi, and then bronchioles are small tubes that branch out from bronchi, and it travels air into alveoli. So basically, and it also transitions into respiratory zone. So basically, to summarize, conducting zone is the physical movement of air going into each lung. You have your nasal cavity. It filters, warms, and moistens your air as it to not, cause damage to the lung, to the lung tissues. And then we have the pharynx, and it's a passageway for air to go from nasal cavity to larynx, and then larynx keeps your creates voice and keeps your airway open. And then we have your trachea, and trachea is a passageway for air to go through from trachea to bronchi, and then it also has goblet cells in its lining, and it secretes mucus and traps dirt, dust, and microorganisms. And then we have your cilia, and they're thread-like too. They're thread-like hairs that are found in epithelial tissues, and then they also move upward and brings your mucus towards your epiglottis in the swallow because it moved upward. And then bronchi are large tubes that split air into each lung, and then bronchioles are small tubes branching from bronchi to bring air into each alveoli, and it also is the transition into respiratory zone. And then now we have the respiratory zone. So the respiratory zone is basically just a gas exchange between carbon dioxide and oxygen. And they include, surprise, the bronchioles, which you already know. And then your alveolar ducts, which basically carry your air to alveoli and are also tiny tubes. And then your alveoli are small sacs that does gas exchange between oxygen and carbon dioxide. So oxygen goes to blood and then carbon dioxide leaves the blood. So in summary, respiratory zone is basically the gas exchange between oxygen and carbon dioxide. Bronchioles are small tubes that branch out from bronchi to split, get air into the alveoli. And the alveolar ducts are small tubes for the air to actually go into the alveoli. And then that's alveolar ducts. And then alveoli are tiny, really small sacs inside lungs that does gas exchange. So they carry oxygen to blood and remove carbon dioxide from blood. Leave the blood. So yeah, that's it. Any questions, comment down below. And then meanwhile, I'll catch you later.